Hello and welcome friends. Through this presentation, I wish to discuss about theory and use of digital level or leveling operation. Already, you are conversant with the fundamentals of land surveying. We have already discussed lot many equipment techniques related with the land surveying through the videos that I have presented for you. Now, we wish to switch over some advanced surveying instrumentation that are designed for land surveying. These advances are not essentially for the techniques, or it does not have kind of timeline, but we wish to discuss these in form of the digitization made for the equipment and its use as such. So let's discuss about some basic things about the digital level. Firstly, it is an automatic instrument. As it is digitized version, it is an automatic instrument. The measuring capability wise, it is quite precise and hence it can be used for the precise leveling. The operations are based on the digital processing of the image of the coded stuff. More about this subsequently. Here, as we go for the availability of the versions, as you see, just in order to understand, I have displayed certain images. So these are the versions. In addition to that, there are a lot many versions that are available in the market. Practically, the usage could be somewhat different, but the way we perform the temporary adjustment, very similar to that. Here also, we have to set the equipment by making use of certain temporary adjustments, and instead of conventional stop, here we cite the barcoded stop. Here, the instrumentation has its own optical system to focus on the stop, and as it catches the image of that barcoded stop, it calculates the reduced level as well as the distance through the inbuilt microprocessors as such. As I refer to some of the material, it is said that such levels are meant for measuring angles. In fact, the versions I see are simply displaying the results in the form of the distance as well as the elevations and are not meant for determination of the reduced levels. Recently, some instrumentation is available which is meant for taking out the stations, and this I am going to discuss as we go for further discussions as well as we go for certain further videos. Though this particular instrumentation is digitized and meant for the precise operations, the way we perform the permanent adjustment for our conventional levels, in the similar manner, we also must assess for a particular level as well as certain coded stop before accepting the data on the field operations. As well, though we do not know much about the sensors that have been provided, microprocessor that is inbuilt as far as surveying operations are concerned, but we must know how that particular say permanent adjustments are valid for that equipment, and if something goes wrong with the inclinity of the line of sight or working of the sensors, what would be its impact on the accuracy of the measurements of the data that we'll be doing on field. And in order to understand that, here it is essential to read and refer the user guide. As well, one must understand that as this particular instrumentation is the digital version, here it may create the harm if it is not properly used. And all that kind of the instructions are available through this particular user guide, and hence for safety, for the care of the equipment as well as for the surveyor and even the maintenance and the servicing of the equipment, one must go very carefully through the guide proper usage of that particular equipment. Now let's understand the bar-coded stuff that we wish to use for this particular leveling operations. Conventionally, we make use of 3 meter, 4 meter, 5 meter, some telescopic aluminum stuff in order to take the readings. Here, the kind of the stuff that we are using is somewhat different. The way you see here, this could be glass fiber strengthened synthetic material, or even it could be invar material in order to make use of it for certain precise operations. In fact, the way we discussed about the digital level and even the staves that we use both have similar optical as well as the mechanical components in addition to the digital capabilities. Hence, both the way you see the instrument as well as even this bar-coded stuff can be used in the conventional manner. Well, the thing is that, as you see here, this stuff is graduated on the both faces. Here, the one side is binary bar-coded for digital reading, whereas the other part is very similar to the graduations for the conventional stuff. Here, you can see that this particular interval is of 10 centimeter. The portion, half of the portion of it is engraved very similar to English alphabet E. Each of these particular divisions read 1 centimeter, and hence accordingly say if we consider the top of the 7, the reading is 0.7. The way we consider here, it will go to 0.01, and accordingly here this entire height of that E shaft will be of 5 centimeters. Hence the top of that E will be giving reading of 0.75. Similarly, this top of 8 can be 0.8. So whenever we wish to make use of this particular stuff for our conventional reading, we can use this particular set due knowledge, and accordingly we can just read that particular stuff. Whereas if the instrument is doing that on behalf of us, we have to just face this coded version towards the telescope. Here, this instrumentation, both that is the digital level as well as even this bar-coded stuff, has got capability to give the data for the precision in two manners. Say, for example, if we think of level of precision as standard, it can help us to measure the reading to 1 millimeter least count, whereas if we consider the distance measurement, it could be measured with the least count of 1 centimeter. We can go for the precision mode within the equipment as it has got that kind of the provision. So here the vertical height can be measured to the tune of 0.1 millimeter, and even the distance can be measured to the tune of 1 millimeter as such. Here, very similar to our conventional instrumentation, we usually follow the distance in between the staff and the equipment more than 1.5 meter, but it has got a measuring capability to the tune of 0.1 millimeter to 1 millimeter as it is expressed in terms of standard and precise measures. In fact, I have shown you some different versions of digital level. But to understand what are the various components, I have chosen one of the brands, that is printer, which is manufactured by Leica Geosystems. So here, this will give us some fair idea about the various parts. Just recall the basic construction of the dumpy level, tilting level, auto set level, and the levels that you are used. Essentially, it has got certain leveling head, and it has got telescope, it has got focusing mechanism through eyepiece as well as the object glass, and the set of the axes which bear the standard relationship. And if that standard relationship is not observed during the temporary adjustment, we go for the permanent adjustment. This is partially valid for this equipment also. Here, the discussion could be extended, but I think it can be spared for a while. See here, what this is nothing but our tangential screw. For conventional equipment, there is a locking mechanism. That is, we go for the clamping screw and we make use of the tangential screw. Here, this particular equipment, when rotated about its vertical axis, it will be getting self-locked, and hence we can make use of this horizontal fine motion screw or the tangential screw for the slow movement of the equipment. Here, what you see is battery compartment, and even some of the version will be having some additional USB ports in order to have the data transferred from the equipment or to the equipment. It is not provided with the longitudinal level tube, but it has got the circular level, pond level as it is popularly said. There is some rough sighting when there is some kind of the V groove on this handle, and it helps us for the rough sighting of the equipment. On the right side, there is a focusing knob. What you see here as shown on the top of the equipment is handle. This is the eyepiece. As you know, as it is rotated, it will help us to focus the eyepiece in order to get the sharp and distinct image of the reticule. Here you have got certain display. So here this display is showing certain things. More about this in shorter while. So this is LCD display. At the bottom there is a set of leveling screws which are connected to the base plate through this leveling head. So this instrument can also be used in order to measure the horizontal angles manually by making use of these graduations. I think you have used the auto set as well as even the tilting level, which has got the similar capability, and you know how this particular angle can be read. Here, the red key that you see here is a trigger key or the measuring key, and this green key that you see is meant for switching on the equipment. Here on the equipment itself, the hazard symbol as well as read the manual carefully is mentioned in order to have the effective usage of the equipment. For conventional equipment, we know how the telescope is designed through provision of objective glass, even certain focusing lens, certain compensating mechanism, the way we discussed about the auto set and the eyepiece. Now what you see here in addition to the conventional provisions is focus encoder, certain detector. Here there is a beam splitter, and these are digitized sensors which are helping us to receive the data as displayed on the LCD screen that we discussed on the previous slide. Here, the light as reflected from the white strips that are provided on the barcoded stop are received at the sensor end, and these are divided into infrared and visible light. The visible light passes to the observer, whereas the infrared portion of it is received by diode arrangement. Here, this barcoded image as is processed through detector diode array, it will be compared with the version that is provided in the memory of this particular equipment. So both the displacement of the code as well as the scale of the code will be read, and it will be transformed into the video signal, which will be getting converted into the horizontal distance component as well as the elevation component for this kind of digital level. As we discussed previously, this equipment is also provided with the axial systems. There has to be line of sight, there has to be the vertical axis, and as the line of sight is getting deviated because of the number of reasons, especially for conventional instrumentation, mishandling and wear and tear. So we know that this particular collimation error does occur with the conventional equipment, and we make use of permanent adjustments in order to make it correct. However, for such kind of the digital versions, we are not, say, much accustomed with the kind of the sensors that have been provided, and we don't know much of the working of it, and hence we don't understand the exact corrections required for that kind of the sensors. So for that, directly the equipment needs to be serviced. However, for the sake of understanding, we can consider that there is absolute collimation error, which is nothing but the deviation of the line of sight from the horizontal axis. And as the sensors or the digital parts are getting affected because of the change in the meteorological conditions, some errors could be variable in nature. So for the digital level or for any digital instrument meant for surveying operations, there could be some optical as well as certain electronic collimation errors. Here, these optical collimation errors can be eliminated by adjusting the reticle, the way we discussed about the conventional instrument. However, here such kind of the instrument are provided with some inbuilt maintenance programs, say for example check and adjust. So these kind of the programs is defining certain procedure, and that procedures are neatly defined through the user guides. So as we perform that, equipment will be able to adjust on its own for the collimation errors that are caused because of the electronic discrepancies. Here, the instrument also offers some inbuilt provisions in order to have the corrections for curvature as well as refraction. Hence, there is no need to have that particular 0.0673D square as combined correction, but the equipment will be getting automatically compensated. For such kind of the understanding, it is better to go for the user guide for adjustments associated with the line of collimation as well as even the leveling vial as it is provided with in the form of that circular level tube. So this is the user face. So this is the platform that we use in order to interact with the equipment. Let's try to understand the keys and their associated function. Say for example, that green button that I had shown you on the previous slide is meant for switching on or switching off the equipment. So it can have the capability to go for function 1 or function 2. So preliminary function for this key is switching on or switching off. Here it does not have any subsequent function. However, on the right side, I had shown you some trigger key, that is measurement key, red in color. So here, if it is pressed, we'll be going for measuring the stuff. Whereas, if we measure it for some period of 1 to 3 seconds or so, it will be able to track the stuff continuously, and it will be giving us the data in form of reduced level as well as distance measurement continuously. In this mode, we cannot go for, say, saving the data, but we'll be able to get the continuous measurement as such. This portion, there is a key which is meant for height and distance measurement. So here just you can see here, this is meant for measuring the height of the star. This is meant for measurement of the horizontal distance, and we can toggle this through the height as well as the horizontal measurement. There is a second function whenever we are in setting mode or whenever we are for, say, in the menu. So at that time, by pressing that, we can just go for upper level in order to switch over to some different functions as such. So practically we'll be using this particular equipment, and at that time I'll be able to demonstrate this effectively. This key D is meant for height difference, and it is the initial key that we start with for the measurement of the elevation. Also, the way you see here, there is certain inverted triangle. So it has second function to make the cursor down in when we are working with menu and setting mode as such. This E is provided with menu. So there are variety of the menus which are again has sub menus. So we can activate or we can select that particular menu. So here there is a second function key. There is a second function for this key which is meant for confirmation purpose, and it is nothing but the enter key. During the dark, especially, say if there is some small shadow or if there is, say, less brightness, we can work with the equipment, but taking the readings or seeing the display may not be of that, say, effective manner, and hence this can be lit with some backlight, and this is termed as backlight illumination. So here this particular, say, bulb sign you can see. This key as a second function we can make use in order to escape, that is coming out of that, say, particular mode. Here when we use the equipment, you will be able to understand this in the better manner. So let's try to understand exactly how that particular, say, height and distance is get measurement. Now you are conversant with these spares of the digital level. You know about the bar-coded stuff, and you know how that interactive keypad is provided for in the form of that user interface. So as just mentioned earlier, the bar-coded image of the rod is captured and compared with the standard image that has been stored in the memory of that equipment to calculate the collimation plane height with initial rough correlations, and as it is done, subsequently it enters into precise correlation through the inbuilt programs. The image correlation procedure obtains the height relationship by displacement of the code. Now here it is obvious that the code that is being read on the stop will be directly proportional to the distances from the equipment, and hence it will go on measuring in relation with the displacement of the code, whereas that scale of the code will be used in order to measure the distances. This data processing is carried out through the microprocessor and the results are displayed directly on that LCD screen. This data could be simply seen, or as it is provided in the menu, the equipment has got capability to store it internally, simply to display, or even to store it externally. So here these kind of the things could be seen during your, say, practical sessions. The procedure that we follow is very similar to our conventional method. Initially, we'll be setting the equipment at our convenient position. You know what are the provisions that we make in order to ensure the stability of the equipment. So we'll be leveling the equipment. Centering is not required. However, if you go for, say, a specific distance measurement or some kind of check and adjustment program, there could be requirement of, say, having the equipment centered through specific distances. We have to focus the eyepiece in order to get the clear image of the vertical here as well as the horizontal here, and subsequently we have to make use of the gun sight to aim the equipment towards the staff. Here, as we bring this vertical hair over the width and try to make it at the center, we can make use of the tangential screw in order to have the staff clearly centered in the field of view of the telescope. Here we have to be very clear about the staff image, as well as the reticle should be sharp as well as the distinct. As we do so, now here we can press the green button, so equipment is on. Just confirm the staff is clearly seen, the images of the reticule are clearly seen, then press the red button, that is major key or trigger key. As you see here, the kind of the mode that you are in, it is displayed on the left side of this LCD. So here the measurement is in standby mode when we switched on the equipment. As we press on this red key, the equipment is in measuring mode. Here it has completed the measurement process, hence the staff reading is shown as 1.235, as well as the horizontal reading is shown in form of the distance of the staff from the equipment. Here, as you see, in the subsequent operation, we can get the reduced level, we can get the difference in height as compared to the previous station, the vertical height as well as the horizontal distance as shown here. On the right side, what you see is the mode, the way we are holding the staff and how it can be operative through the remaining life of the battery. Okay, more about this in subsequent discussion. So there are many advantages as far as use of the digital level is concerned, and that is too obvious. Here, as I mentioned here, the collimation correction is required. However, it need not be performed through the manual adjustment, but there is an inbuilt program. So even this can be done manually and the corrections can be done and entered manually. We need not have the optical means to measure the readings manually, but here the readings are read automatically and that are booked, worked out with the reduced levels. So there is no need to maintain the field book. If one is in need of for the confirmation, one can have certain keynotes, but it is not an essentiality. The interface as such is very user friendly, so one can easily read and interact with the equipment, and one can have their own versions for the effective usage of the equipment. As I mentioned here, we need not bother about the earth curvature as well as the refraction errors because that are compensated automatically. Even as we have the similar provision of the staff as well as the equipment for the given condition, the data will be consistent and even it is reliable. You can see certain recent studies here. For our conventional level, the time required for the evaluation, measurement as well as the data processing is quite high as compared to that of digital level. Even the manufacturers give certain say conditions. So here you can see that equipment is quite fast and we can save considerable time on site. Applications need not be discussed because already you are well versed with the usage of the level. So whatever that we can do with conventional level, the same can be done in much better manner by making use of digital level. Okay, so here we can make use of this for measurement of the elevations. We can work out the height differences. We can determine the gradient. We can set the gradient. Even as this particular equipment has got the steady interval as well, even the distance measuring capability, we can set out the horizontal distances. Even we can have the inverted staff readings in order to have the horizontal platforms at the various levels in level condition. So let it be simply ceiling work, or it can be soffit of the tunnel, or it can be the position of the booms, it can be the depth of the excavations, and it can be the gradient of the say road surfaces, side gutters, and lot many such things. Okay, so well friends, I think the discussion that we made would help you in order to understand the theoretical background and fundamentals of digital level for its better usage in the field applications. So thanks for your attention. We'll discuss about the practical usage of the digital level, okay, subsequently. So I wish you very happy learning. Thank you.